Welcome to the video for practice test question number 4 for the chapter 14 practice test for math analysis. Question 4 gives me a function, two functions actually, if f of x equals 5 minus 2x and g of x equals x squared plus 2x. Find f of g of x, find x when g of x equals 20, and find the inverse of f of x in the form ax plus b. So three different problems there, really. F of g of x is really the same as question 3. I'm plugging an expression into f of x. So I will take g of x, x squared. Actually, when I write it, I will just write to remind myself that I'm doing f of g of x. I'll write f of g of x. But then when I say equals, I'll say 5 minus 2 times x squared plus 2x. So f of g of x equals 5 minus. Now I simplify it. So get rid of parentheses, combine like terms. To get rid of these parentheses, I have to use the distributive property. Minus 2 times x squared is negative 2x squared. But I can't just multiply it by x squared. If I add first, like PEMDAS tells me to do, I would end up multiplying negative 2 times both of them. So I'm going to do that. I'm going to multiply negative 2 times 2x minus 4x. Oops. Almost wrote squared. But I just have negative 2 times positive 2 and then times x. I don't have x squared. And just to clean it up a bit, I'm going to put it in order. You don't have to do this. Negative 2x squared minus 4x plus 5. Question B says find x when g of x equals 20. So g of x equals x squared plus 2x. So I'm going to say g of x equals 20. I'm going to put 20 where g of x is. I'll say x squared plus 2x. First of all, there's one way I can see right off to work on this. I need to get, when I have a quadratic formula, a quadratic equation, I need to have it equal to 0 for all of the methods that we use to solve a quadratic equation. So I'm going to subtract 20 from both sides to give me 0. X squared plus 2x minus 20. Now the easiest way to solve this is going to be to factor. So I need to find something to multiply to give me negative 20. Can't do that. So 5 and 4, or 2 and 10, have to add to give me 2. So I'm not going to be able to factor this one. I'm going to have to use the quadratic formula, which is fairly straightforward. So first of all, I need a equals 1. B equals 2 from here. A is this coefficient, B is this coefficient, C is the term by itself. And I can say this is a 1 because 1 times x squared would still be x squared. So I can call that coefficient 1. So x equals negative b plus or minus square root of b squared minus 4ac divided by 2a. So in other words, x equals negative 2 plus or minus the square root of 2 squared, which is 4, minus 4 times 1 times c. So 4 times 1 would be negative 4. Negative 4 times 20 is a positive 80. And I'm going to divide that by 2 times 1, which is 2. A is 1, 2 times 1 is 2. So once more, equals. This is 84. Square root of 84 is a little bit more than 9. So I'm going to say negative 2 plus 9.1 divided by 2, or I'm splitting it out now. X equals negative 2 minus 9.1 divided by 2. The plus or minus is actually going to give me two different results. This would be 7.1 over 2. So x is approximately equal to 3.5. Or negative 11.1 over 2. So x is approximately equal to negative 5.5. Question C asks me to find the inverse. So f inverse of x. To do that, I put a y where the f of x is. So I'll go back to my f of x. F of x equals 5 minus 2x. So I'll say y equals 5 minus 2x. Then I change places with the x and the y. So I put x equals 5 minus 2y, because I'm going to want to go the other direction. And I solve for y. So subtract 5 from both sides. And divide both sides by negative 2. So negative 2 divided by 2 is 1. I'll get y over here. I can call that now f inverse of x. That's what I'll call my y. And I have x over negative 2 plus 5 over 2. And if I put it in the form ax plus b, I'm going to write it this way, and I'll change it around just so we have the function symbol on the left. And I'm going to say negative 1/2 x plus 5 halves. And that gives me the ax plus b form. A is negative 1/2 and b is 5 halves.